So central to everything that we do at Saber is our testing. We want to make sure that every one of our products is tested to destruction, so we know where it's going to break, how it's going to break, and at what point it breaks, to give you confidence that the gear is going to get you home. Let's talk a little bit about our testing regime. We've got a whole lot of broken stuff here.
That's right, Ben. We've got a whole lot of our broken gear laid out on the table in front of us. And I guess it goes to the fact that we do actually start with a batch test. So we don't just do a single test on a single shackle or 2 or 3 shackles of a particular design and then say that's the number for that product from here and evermore. Every single time we go about constructing a new batch of products on a particular range, we pull 3 out. In an original product, we start with 5. But then each batch after that, we pull 3 out. They're destruction tested, and they all have to exceed the braking strength that we've set for that product.
So on all our products, we've got our warning labels, whether it's a soft shackle or if it's etched in on the alloy or on stickers on our other hitches. We actually put a batch number on there. So we can go back at any point and say, okay, this batch here is AU20238. We could go into our system and we could find the test results from that batch, if and when we ever have an issue or otherwise, or we've had that question asked for military use or other fleets that need certification that the products will meet the needs they need to meet.
Yeah, it's interesting you say certification. That's one of the other things. In the four-wheel drive industry, there are no real guidelines as such as to what we should do from a testing point of view. What we've done at Saber is essentially come up with our own set of guidelines that we're comfortable in making sure that this gear is the right gear for you.
Yeah, that's right. There are no Australian standards for soft shackles, even for kinetic ropes. But we've made sure our kinetic ropes actually comply very closely to what's required for snatch straps. Obviously, the main difference is we just don't stitch a label in, because you can't stitch a label into a rope as you can a strap. Outside of that, we meet all the testing requirements for the kinetic ropes.
And I guess the other thing too is we're prepared to do a lot of extra testing. So recently we did there was an interesting YouTube clip on different ways of tying, and this is the testing we do. And again, this was more than what you would normally do. So we put 5 shackles for each of the different categories. So we'd seen online, there was a slackline video that was talking about a different way of tying the soft shackle off in a figure 8, and it was supposed to theoretically increase in strength if you did that.
I think they said it was 20% stronger or something like that.
Yeah, it was somewhere between 10 and 20% stronger, and we were very keen because we're pretty sure we know the best way to do all these things, but when we had seen this video, we thought we'd better test it. There was also an article that had come out that said soft shackles are weaker when they get wet, and we knew that wasn't right. We knew this fibre, doesn't react the same way. We know nylon in our kinetic ropes, and nylon the same in snatch straps. When you get those wet, they do get up to 30% weaker.
Yeah, and look, Saber Pro with the coatings we put on it and the fibre themselves just do not absorb water.
Yeah.
But we wanted to obviously prove that.
Well, we had to prove it. I mean, that was one of the things we set out to do in that same test. And then on top of that, we took 5 shackles out of that exact same batch. So all 15 of these shackles are from one batch, and broke them as well so we could get a baseline.
Standard test.
Yeah.
So you had 5 of these. You put them in a bucket of water.
Yep, they were in a bucket for a week.
They float. So you put a brick on top.
Had a brick on top of them for a week.
So we took them out. We left them in some water. Took them to the testing facility. Then we broke them.
Yep. Now, interestingly enough, I like to say that they were stronger when wet. Now, statistically, what was it, 3%?
3% stronger.
Yeah. So we found out that they were only 3% stronger, but they're certainly not weaker when they're wet.
And that's the point. You don't have to worry about our soft shackles getting wet. They don't get weaker. But, again, we can't say they're getting significantly stronger, but certainly they're not getting weaker. What was interesting was when we put it into the figure 8 construction, it actually broke about, again, 3 or 4% weaker than our standard shackles. So again, it was one of those things where we couldn't definitively say that it was a lot weaker or even equal to, but it certainly wasn't stronger. But that's what we do. We don't simply take a product, we've tested it for this batch, let's not worry about it, how else it could be used. We actually take it to as far as we need to take it to get the information we need.
So now we're using a NADA lab. Do you want to talk about the NADA lab and tell people what is the NADA lab and why we use NADA labs?
So in Australia, the labs need to be accredited nationally, and that's under the NATA program of accreditation. The good thing about that is when we use a NATA lab, we know that every time we use that machine, the results are going to be the same. They're obviously calibrated to that. So when this shackle breaks at 10 tonne at the NATA, at the same lab, and it breaks at 10 tonne again, we know the machine is still doing what it needs to be doing. We have confidence in our results. I said before about destruction testing and we take our products to destruction. It's not always true.
That's correct.
There are some products in our range that we have failed to break. This has been a one that we're pretty proud of, and I'm going to get you to hold it because it's nice and heavy.
It's nice and heavy. So this is our steel rear recovery hitch that we came out with, and originally we tested it with a single pin sheared at, I think it was about 14 tonnes. We then went to 2 standard pins. I think that was around 30 tonnes for the 2 standard pins. Then we went up a grade, a bolt, same sort of problem. Then we got to, I think it was like early 40s. But still really, we hadn't done any damage at all to the rear hitch, and we like to get on our socials and we love to tell everybody that we're all about breaking and doing our destruction on everything. So we were keen to break it. So we had to step it up one further. And so we went to 2 12-9 pins, which clearly you're not going to get on the rear of your car.
No.
But we went to that and took it all the way out to 61 tonnes. Now at 61 tonnes, we've actually bent the pin in the steel bow shackle so that it can't get undone.
And if you actually look at it, which you can't see easily, if I could oxy this off, which we could eventually, I could virtually sell this hitch. It is still perfectly round on the inside. It's got a couple of marks where some of the pins actually let go, but other than that, this is ready to go at 61 tonne.
So there's zero deformation in that. Now, again though, we do actually only rate that at a 5 tonne working load limit. We do that because of what your rear carriage is on your vehicle.
Correct. I mean, we've also got our alloy hitch. Same sort of story again. The difference here is, as you can see with that bow shackle, you won't get that through here. So we're limited here at this point in time with the rope that we can get through here. We've got to, with the 2 12-9 bolts, at about 35 tonne, but again, we rate this at a 5 tonne working load limit.
So the 35 tonne, we didn't actually break the bolts, we actually broke the rope.
The rope broke, correct. Obviously also from a NATA accreditation perspective for the batches is one thing, but development's also important. Do you want to talk a little bit about the alloy winch shackle that we're about to release into the market? And a little bit about pins and otherwise, because this is what makes us a bit different again.
So I guess it's a product development, research and development part of what we do here. We're always looking at how different materials work together. We've tried different grades of alloy. We've tried all sorts of different pins, right from titanium right through a range of stainless steel, gone to heat-treated stainless. We've looked at different alloys. This one in particular we broke today was a 6061 alloy, when we're just comparing that back against what we've done with our other ones. The one that we've actually got coming through at the moment is a 7075. We know that's a really high grade, really strong alloy, but we were keen, and this I guess when we talk about our testing, we were keen to see what the difference was and to learn from that. And we did learn a few things today about how that material works.
That's right. And it's one of those things where just because some companies may have done it one way or the other doesn't mean that we need to continue to do it that way. You know, if we think we can improve it, we can do it a bit different, we will.
Now we also tested something else today.
Oh, here we go.
Tell everyone what we tested today, Ben.
Okay, so today we actually tested, and we've talked about it a lot, but we actually tested today the world's strongest keyring. These actually, again, all this really cool stuff we've broken is one thing, but to test the keyring and to break it at over 3 tonne was awesome.
Yeah, and look, it really is one of those things we wanted to do. Like everything else, we're rope guys. It is a soft shackle that we're using for the keyring, and we wanted to make sure there's one that's not broken. But what we wanted to do, like everything else, we do like to break things. So we were all about making sure that we could break this too.
Indeed we did.
And we did. 3,000, what was the average on the
3,300 kilos.
There you go.
So I hope that gives you a clear understanding of what it is that we do at Saber when it comes to testing. We want to make sure that this gear is strong, this gear is durable, and this gear will get you home.